Uh, Today we are discussing about the creation, annihilation and number operators. Uh, First of all, we will discuss about the contribution of radiation oscillators. At the end of the 19th century, it was recognized that the space-time development of the radiation field satisfying the wave equation del square A minus 1 upon c square del square A over del t square equals to 0. Now by assigning an average energy kT to each radiation oscillators, Rayleigh and Jeans wrote an expression for the energy distribution of the radiation field which holds for low value of omega and sufficiently high temperature but fails at higher values of omega. This difficulty led by Planck by the assumption Planck hypothesis that the energy of each radiation oscillator is not an arbitrary quantity but must be an integral multiple of h cross omega, where h cross is equals to h upon 2 pi, where h is the Planck constant. You are well familiar about this hypothesis. After that, Palm-Dirac proposed that the canonical dynamical variables of radiation oscillator be treated as non-commutable operators just as x and p, or of a one-dimensional harmonic oscillator are treated in non-relativistic quantum mechanics. Let P and Q of the radiation oscillators are operators satisfying the conditions Q P equals to iota h cross del kk dash del alpha alpha dash, and the Q k equals to 0 and P equals to 0. Now we consider the linear combination of P and Q operators such that A equals to 1 upward square root of twice h cross omega q plus iota p, and A dagger represented as 1 over square root of twice h cross omega q minus iota p, where A and A dagger are analogous to the Fourier coefficient C and C dagger, and they also satisfy the commutation relation. That is, A dagger equals to minus iota over twice h cross qp plus iota upon h cross twice h cross pq, that's equals to delta dash, and A k alpha A k dash alpha dash equals to A dagger k alpha A dagger k alpha equals to 0. Now let us define an operator n k alpha known as the number operator such that n k alpha equals to A dagger A. Now A n can be written as, using equation 7, A dagger A minus A dagger A, and this can be written as A dagger A minus A dagger A, or A n equals to delta kk dash delta alpha alpha dash A k alpha. Here I leave the subscripts which are already shown in the video, and in PDF you will see. So you should use these subscripts, but I leave here for my sake of simplicity. Similarly, we can write A dagger n equals to minus delta kk dash delta alpha alpha dash A dagger k alpha. Let be the eigen value of operator n in the state n, that is n equals to n state n, because n is Hermitian, so n must be real because it is the property of Hermitian operator. The eigenvalue of any Hermitian operator must be real, so small n must be real here. Now n A dagger n can be written as A dagger n plus A dagger over n, since n A dagger minus A dagger n equals to n A dagger, or we can write it as n plus 1 A dagger n. Similarly, n A n equals to n minus 1 A n. Equation 10 and 11 shows that the role of A dagger and A, that is A dagger is a eigenvector that increase the eigenvector by 1, so it is known as the creation operator, n to n plus 1, so it is known as creation operator. While A is an eigenvector that decrease the eigenvalue by 1, that is n minus 1, so it is known as the annihilation operator. This means A dagger n can be written as C plus n plus 1 and A n equals to C minus n minus 1, where C plus minus are the constant of determined. C1 plus minus we evaluate C plus square can be written as C plus square n plus 1, and we can write A dagger n A dagger n, that is n plus 1. Similarly, C minus 1 square equals to n. Therefore, from equation 12, 13 and 14, this is 14, we can write A dagger n equals to square root of n plus 1, A n equals to square root of n, and while n is the value that should be greater than 0. Since the normalization of A dagger A n must be the positive definite, this tells that n cannot be a non-integer. If n is a positive integer, then from A n equals to square root of n minus 1, give A0 equals to 0, A1 equals to 0, A2 equals to root 2 1. The matrix representation of A can be written as 0, 1, 0, 0, 0 and so on, 0, 0, square root 2, 0, 0 and so on, 0, 0, 0, square root 3, 0, 0. And similarly for A dagger and n, we can write 0, 0, 0, 0, 1, 0, 0, 0, 0, root 2, 0, 0, 0, 0, root 3, 0, 0. Here you can see the from this for the value of A, the first row is started by 0, 1, 0, 0, while in A dagger it is started by 0, 0, 0, and further that the second row is 0, 0, 1, root 2, 0, 0, 0. Here the first row and first column, first column and second row is 1, 0, 0, and third row is 0, root 2, 0, 0 and so on. And the value of n is 0, 0, 0, 0, 1, 0, 0, 0, 0, 2, 0, 0, 0, 3, 0. So that's about all about the creation, annihilation and number operator using the quantization of radiation oscillator. Thank you.